Let's now, it's still, we keep working on recognizing chiral centers in a molecule. So let's do this molecule here. So 1, 2, 3, 4, so 2-chlorobutane. Now here we have CH3, not a chiral center. Carbon here has a hydrogen. And again, remember in a tetrahedral carbon, the sp3, we had 2 bonds in the plane. In 2 off plane, one is in the wedge and the other in the dash. So here, if chlorine is in the wedge, the hydrogen is on the dash. So here you have your 4 bonds, 4 different substituents. So this is a chiral center. Now I'm going to use this dot. This is CH2, not a chiral center. This is CH3, not a chiral center. Let's move on to another molecule here. And this has an OH here, 1, 2, 3, 4, 5, 6. So this is 3-hexanol. Let's write that down. And the name for that is 2-chlorobutane. There is an element here that we haven't included, which is the stereochemical designation of the chiral center. We haven't studied absolute configuration. We will. But for now, this is the name. And now identifying chiral centers, which is the goal here. I need a hydrogen here. It needs to be in a dash, 2 in the plane, 1 wedge, 1 dash. And here I have 4 different substituents, OH, hydrogen, the ethyl, and the propyl. So 4 different substituents. That's chiral. That's not. It's CH3, CH2, 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 CH3, not. So this molecule has 1 chiral center. This also has only 1 chiral center. Now, this one here. Now this molecule has in this carbon, we know that we need a hydrogen, right? We need to have 4 different substituents. And analyzing those, bromine, hydrogen, those are different. This chain is different to that, traveling this way. So that is a chiral center. This is sp2, sp2, not. This is CH2, CH2, not. Now, this molecule has only 1 chiral center. Now, let me do something else. Let's say that molecule here. Now, with looking at the carbon that has the bromine, I have the hydrogen there. So bromine, hydrogen. Now, let's analyze. These 2 are different. Let's analyze the other chain. Now, actually, if you travel this way, you see carbon double bond, and the CH2. Traveling the other way is the same. So these 2 substituents are identical. So this is not chiral. This molecule has symmetry. You can put a plane here. And this molecule is lacks a symmetry, so it is asymmetric. And that is a chiral molecule. So molecules with 1 chiral center will be chiral, but molecules with more than 1 chiral center may or not be chiral. Those are something that we're going to study later. Now let's do a few more examples about recognizing chiral centers. And let's see. So always your checklist, check that you have the chiral centers are going to be sp3 carbon with 4 different substituents. So let's go and draw a few more molecules. And a couple more. And this one here. Okay. Right, so let's analyze that. First molecule here. Now I have in the carbon here, I need a hydrogen. That should be in axial because the OH is equatorial. And now analyzing the other chains, CH2, 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 traveling this way, traveling the other way, CH2, CH2, CH2. Actually, this doesn't have chiral center. This is not a chiral center. This molecule actually has symmetry. You can do another drawing to make it easy on you, but if you have this, so pointing up like that, easy to recognize a plane of symmetry. So not chiral. Lacks of chiral center. Now, molecule here. Notice that this carbon, OH in axial, H in equatorial, OH equatorial here, H in axial. It's just completing the 4 bonds. Now analyzing the carbon here, this one has an OH, an H, and now traveling this way, this chain is CH2, 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 and that with the OH. Traveling the other way, immediately you have a carbon with an OH. So completely different than traveling from the other side. So this is a chiral center. Now let's analyze the other carbon. I have an OH, an H. If you travel this way, it's different than traveling the other way. So 4 different substituents, that's also a chiral center. So this molecule has 2 chiral centers. Now let's look at the molecule here. Let's do this one first. I have, this is the CH3, so obviously it's not. Here at this carbon we have a hydrogen. So metal, ethyl, hydrogen, and this chain is different, so that is a chiral center. So I have this one. The carbon next to it has a metal, and I need to have a hydrogen, so it should be on a wedge. So metal, hydrogen, this chain over to that side is different to the other chain, so that's also a chiral center. Now this is sp2, sp2, this is CH3, so 3 substituents are the same, CH3. So this molecule also has 2 chiral centers. Now let's move on to this molecule. CH3, not a chiral center. Carbon here has this metal and it needs a hydrogen here. So we'll have metal, metal, hydrogen. So notice has a metal here and a metal here, so not a chiral center. 2 substituents are the same. Now, if I'm moving on the other carbon, I here need a hydrogen on the wedge to complete the 4 bonds. In the molecule here, we have a metal, the carbon, a hydrogen, and now on this side, I have an isopropyl group. And on that side, I also have an isopropyl group. And let me highlight that. The isopropyl group is this. So the carbon in the center has actually 2 isopropyl substituents. There will be another hydrogen here. But that's not what you, important is that you have this pattern. That pattern is isopropyl. And it is the same on both sides, so that's not a chiral center. Lastly, we have the carbon here. And this carbon has attached a metal, that is a switch, in another metal, so not a chiral center. This molecule lacks a chiral center. So this molecule is achiral or non-chiral. We will continue studying this topic in more videos.